Hi there. In this lesson I'm going to go over everything you need to know to get started using rocket motors. This lesson will be split into 3 parts. Firstly, how do rocket motors work? Secondly, how are rocket motors labelled? And finally, which motor is the right motor for me? Just a warning, part 1 might get a bit confusing. Don't worry if you don't understand, the good thing is you don't need to. That's all been considered already for you. So, let's dive into it. Part 1. How do rocket motors work? You've probably seen the thought experiment of an astronaut floating in space with a hammer. Well, what should they do? Yes, of course, they should throw the hammer. It's the exact same principle with rocket motors. In this case, the astronaut has mass, and when they throw the hammer, which also has mass, in the opposite direction, they too get sent backwards. This is Newton's third law. Isaac Newton stated that every action has an equal and opposite reaction. That's exactly what happens with rockets. Like the astronaut, rockets also throw things in the opposite direction. Just not hammers. Instead, tiny particles of gas. Rockets don't push on air, they don't need wings, and that's why they can work in space, where there is no air. Instead, they push themselves forward by throwing mass, in this case hot exhaust gas, backwards very fast. The faster and heavier the mass being thrown backwards, the more thrust the rocket will have. That's why rockets with more fuel or more burn time have a higher thrust. Even though it may seem confusing, the only thing you have to know is that rockets go forward by throwing mass backwards. Now let's have a look what gets thrown backwards. In front of me I have a selection of rocket motors. Within each motor you will see the propellant. This propellant burns and gets thrown out of the back of the rocket very fast. That is the mass which produces the thrust for the rocket. But how do we know the difference between all of the motors? Well, that comes down to the codes on them. Part 2. How are rocket motors labelled? Now we know how rocket motors work, let's decode the mysterious numbers and letters on the side of the rocket engines. For example, C65, like on this motor here. These codes tell us exactly how the motor will behave. Here's how it works. The first letter, in this case the letter C, stands for the motor classification, or the total impulse. Motors are classed based on their impulse. This is a measure of the total power of the motor. Motors in classification A have a low power. B is double A, C is double B or quadruple A. So this means that the C motor that we have here is 4 times as powerful as an A motor. You can see this here, this C motor and this A motor. The C motor is about 4 times as large. Next is the first number, in this case a 6. This number teaches us the average thrust of each motor, or the push each motor gives. This is recorded in newtons. This number will tell you how strongly the motor pushes while it's firing. The higher the number, the more thrust, and thus a faster takeoff. The second number, in this case 5, refers to the delay time before ejection. This is measured in seconds. This is the delay between the motor burnout and the parachute ejection. It's important our parachute comes out at the right time. So knowing what these numbers mean allows you to get the right motor for your rocket. If the delay time says 5, then 5 seconds after burnout, the parachute pops out. Too early or too late can mess up a recovery. So to summarise, the C at the front refers to the motor classification or the total power. The 6 in the centre refers to the average thrust or push the motor gives. And finally, the 5 at the end refers to the delay time between motor burnout and parachute ejection. Once you learn this system, you can read any motor label. Part 3. Which motor is right for me? Now you know how rocket motors work and how they're labelled, the important thing is choosing the right one for you. This depends on a number of factors: the rocket weight, the launch field size, the desired altitude, and finally, the delay time. A very light rocket will be able to fly on an A motor, or perhaps even a half A motor. However, heavier rockets may need a B, C, or even a D motor. However, if you have too little power from your motor, the rocket may not even leave the launch pad. Next is the launch field size. Bigger motors go higher. However, when the parachute ejects at apogee, the wind can take the rocket a long way away. So you may choose to fly a lower power motor so that your rocket won't go as far. If you're in a small field or close to buildings, you may want to think about reducing the size of your motor. This will limit the risk of your rocket landing on the buildings or going too far away. Third is the desired altitude. If you want your rocket to go to 100 feet or 1000 feet, you will need different motors. Higher power motors will go higher. Lower power motors will go lower. If you want a low flight, perhaps think of an A motor. If you want a higher flight, perhaps think B, C, potentially even a D motor. However, only if you have the space. Finally, once you've selected your motor classification, you will want to choose the motor with the right delay time. If your rocket won't go too high, perhaps you'll want a lower delay time. However, if you have a high, fast rocket, you may want to look at a higher delay time to stop the parachute coming out too quickly. This could damage the rocket. Recommended motors for beginners are B64s and C65s. If you want to find out where to buy these, check our vendors list on rocket-school.org. Make sure, especially for your first time, to launch in a big open space. The safest place to launch are at clubs. You can find information about rocketry clubs in the UK on our website. Finally, if you purchase a kit, it may recommend certain motors to you, or perhaps come with a motor. In that case, just insert the motor and head to the launch pad. Always remember, follow the safety instructions at your launch site, and don't use a rocket motor that you feel uncomfortable using. Finally, I'm going to talk through some of the things I have in front of me. At the very start here, we have the A motors and half A motors. You can see they soon get bigger to a B, C over here, and then D. By the time you have a D motor, compared to the half A, it's about 8 times as big. Now, you've got rocket motors like these. These come in an enclosed case and are single use. However, you can purchase a reusable case. If you have a reusable rocket motor case, you can then purchase these. These are grains of propellant which go inside your case. As you work your way up, you may find yourself using rocket motors as big as these. Just don't forget, if you have any questions, ask for help and follow the safety instructions. Good luck with all your launching, and I hope to see you again soon. Have fun!